Hey guys, what's up? Welcome back to your 10th C tutorial. And today's lecture is going to be pretty short and sweet, simple. I'm going to talk to you guys about typecasting and the ASCII chart. Both are really simple topics. So let's go ahead and just dive in. So let me get started typing up this program before we start because it's pretty simple. I'm just going to have the compiler do a little arithmetic within my program, and we're gonna see a wrong value, and I'll tell you guys why it's wrong, and then I'll introduce typecasting to show you how we can fix that. So here I've just declared a float called num, and I haven't given it a value yet, but I'm going to give it a value and we're going to print it. So let's say I want num to be 15 divided by 4. Oops. So 15 is not evenly divisible by 4. We should get 3 and some change, like 3.75, I believe. So let's try this on the calculator. Oh, yeah, here it is. But just so you guys can see for yourselves, 15 divided by 4 should be 3.75. So let's see what the compiler gets. The compiler returned to us 3.000, etc. So this is clearly the wrong answer, and I know you guys are thinking, okay, well, what's going on? We did a perfectly, legal syntax, 15 divided by 4. Why are we getting the wrong number? And the answer is we're getting the wrong number because we gave the compiler two integers, 15 and 4, two whole numbers, and it gave us back a whole number. And basically, another way to look at it is that we gave the compiler two values with precision of 0, and precision of 0 means that there are 0 numbers after the decimal point in both of these numbers. So whenever you do arithmetic, the compiler is always going to return the most precise data type back to you. So this is where typecasting comes in. Let's say I wanted the exact answer. I don't want a roundabout answer of 15 divided by 4. I want the exact answer. So we're going to ask the compiler to treat 15 as a floating point number, meaning we're going to ask it to treat it as a decimal point. And let's see what happens. Bam. There we go. We get 3.75. And so, again, now we're not just working with two integers. We're working with an integer and a float as far as the compiler is concerned, and we can change this to double. You can change it to character. I'm not sure what happened, but that's typecasting in a nutshell. And it also works with variables. So I is equal to 15. It doesn't have to be two constant values. So we should get 3.75. There we go. We get 3.75 again. So I just want to show you guys that. And lastly, I wanted to show you guys the ASCII chart. So bear with me. The ASCII chart is actually pretty cool. I don't know if you're a nerd like me. ASCII table. Typically, I just Google it and I go with the first results that are pulled up. Come on, Google. There we go. Go to images. And here we go. So if you guys notice, this is this big crazy looking chart. All we're going to be focused on are the decimal, the column with the decimals, and the character column. And so within programming, there's always several different ways to represent one set of data. So for example, if we print out the value 65, the decimal value 65, as an integer, we're going to see 65, but if we print it as a character, we'll get the letter A. Well, let's do 64 instead. Let's do 64. So here, if I say, okay, compiler, interpret this number as a character, and I want you to print 64. Let's see what it gives us. It gives us the @ symbol, right? So if I were to change this to a D, then it would just give us 64 because we supplied a decimal and we wanted it to print a decimal. This can come in handy other times. For example, if we take in a string from a user and we wanted only uppercase letters, well, all we would have to do is convert these to integers, and if the integer is within the range of 65 to 90, then we know we just have uppercase letters. If not, then we could, tell the user, hey, this isn't uppercase, you did something wrong, whatever. So this is pretty fundamental stuff. I don't think anyone remembers this or memorizes this sheet, but it's pretty good to have at your fingertips and just to know that it exists, period. So that's it for today's lecture. I'm not sure what the next one will bring, but I'll see you guys there. So thanks for watching.